This is section 1.7, solve absolute value equations and inequalities. Here I can statements for this section. I can solve absolute value equations and inequalities. An absolute value is the distance a number is from 0 on the number line. And when we write the absolute value, we have those two vertical lines on either side of it. Absolute values are always going to be a positive number. Extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. When you go to solve an absolute value equation, use these steps to solve the absolute value. So if we have the absolute value of ax plus b is equal to c, where c has to be greater than 0, it has to be a positive number. The first step is we're going to write two different equations. We're going to write ax plus b is equal to c, and then we're going to write ax plus b is equal to a negative c. We're going to solve each equation, and then we're going to check to make sure each of them are actually a solution to the original absolute value equation. So we're going to solve and then graph our solutions. The first thing we do is we're going to write our two different equations. We're going to write x minus 2 is equal to a positive 1. And we're going to write x minus 2 is equal to a negative 1. If we solve the equation on the left, we're going to add 2 to both sides. And this is going to give us x is equal to 3. Over here, if we add 2 to both sides, we're going to get x is equal to a positive 1. Now we're going to check to make sure they actually work. So if we substitute these back in, 3 minus 2 gives us 1. And 1 minus 2 gives us negative 1, but this is inside the absolute value. And the absolute value of negative 1 is a positive 1. So both of these are solutions. And if we graph both of these equations, both of these solutions, we will have a point at 1 and a point at 3. These are both 1 unit away from the value of 2. They should be equidistant from that center point. Now we need to find the absolute value of the equation. Again, we're going to write the two different equations. So we have 5x plus 10 is equal to 25, and 5x plus 10 is equal to a negative 25. On the left, we subtract the 10 from both sides. We're going to have 5x is equal to 15. Right now we have 5 times x. The opposite of multiplying is dividing. So we're going to divide both sides by 5. And we're going to get that x is equal to 3. On the right side, if we subtract 10 from both sides, we're going to have 5x is equal to negative 35. Divide both sides by 5. We're going to get x is equal to a negative 7. Now we do need to check to make sure both of these work. 5 times 3 is 15. 15 plus 10 is a positive 25. 5 times negative 7 is negative 35 plus 10 is a negative 25. We are inside the absolute value, so that will become a positive 25. Once again, we're going to do the two different equations. We have 2x plus 5 is equal to a positive 3x. And we're going to have the 2x plus 5 is equal to a negative 3x. If we solve for x, we subtract 2x from both sides. We have 5 is equal to x. On the other equation, if we subtract the 2x from both sides, we're going to have 5 is equal to a negative 5x. To get the x by itself, we're going to divide both sides by the negative 5. And we're going to get negative 1 is equal to x. Now we have to check for any extraneous solutions. We're going to make sure that they actually work. So if we plug in the 5, 2 times 5 gives me 10. 10 plus 5 gives us 15. 3 times 5 gives us 15. 15 equals 15, that's going to work. But if we plug in the negative 1, 2 times negative 1 gives us a negative 2, plus 5 gives us 3. And 3 times our x, or 3 times negative 1, gives us a negative 3. positive 3 does not equal negative 3, so x equals negative 1 is an extraneous solution. It does not satisfy the original equation. So the only answer for this problem is x is equal to 5. Now we are also able to solve absolute value inequalities. To do this, you're going to create two different equations. You're going to drop the absolute value sign, keep one the same, and you're going to switch the sign of the answer and the direction of the inequality of the second equation. Then we're going to solve each equation and write out the answer. So when we have an absolute value inequality, you are going to keep one the same. For the second equation, you're still going to drop that absolute value sign. So we're still going to have 2x minus 7. But we are going to reverse the inequality sign, and we're going to change the sign of the answer. Again, we're going to solve both of them. So I'm going to add 7 to both sides. So we have 2x is greater than 8. Divide both sides by 2. And we will get x is greater than 4. On the other side, if we add 7 to both sides, we have 2x is less than 6. If we divide both sides by 2, we're going to get x is less than 3. And we need to make sure that they work, so we're going to plug them back into your equation. 2 times 4 is 8. 8 minus 7 is 1. So anything above 4 would be greater than 1. On the other side, we have 2 times 3 is 6. 6 minus 7 is negative 1. And the absolute value of that would be a positive 1. But we are looking at all values that are less than that. So if we look at a value less than 3, if we look at 2, 2 times 2 gives us 4 minus 7. It's going to give us negative 3. The absolute value of negative 3 is a positive 3, which is greater than 1. So those solutions do work. So we're looking at 4. But it's not 4, it's greater than 4, so it's an open circle at 4, and it is greater than, so we're shading to the right, or less than 3, so it's an open circle at 3, and we're going to shade to the left with the arrow because it's going to continue all the way to the left. Once again, we're going to have the two different equations. The first equation is going to remain the same. The second equation, we drop the absolute value. We are going to reverse the inequality sign and change the sign of your answer. So when we go to solve, we're going to add 3 to both sides. And then the two solutions we should get are x is less than 5 and x is greater than 1. So if we pick a value that's less than 5, let's say 4. 4 minus 3 is 1. The absolute value of 1 is 1, and that is less than 2. If we pick a number greater than 1, let's say 2, 2 minus 3 is negative 1. The absolute value of negative 1 is 1, which is less than 2. So these solutions work. It's going to be between 5 and 1, because it's less than 5, but greater than 1. Those are both open circles, because it's just less than. And we are going to shade between them.